know, basically. Okay, so we're going to try this. Normally my internet connection should be slightly better, so this may actually work. Let me know as a comment if the quality is just too poor or something, but hopefully this should work out quite nicely. Okay, so if one of you can make a quick comment, that would be great. Okay, perfect. Okay, everyone, so do let me know again if really the sound is bad or something, just tell me. In theory, though, this should actually work out quite nicely. Now, the idea today, following the exercises that I sent you yesterday to work on, it's all based on logarithms, right? So IGCSE logarithms. And in fact, we're actually going to go a tiny bit further than IGCSE logarithms with the IB in mind, okay? So here's the idea. The first thing we're going to be working on here are the 4 questions that we have here. And what I'll start with is really remind you what a logarithm actually is, okay? Now, to begin with, let's say I'll just write this. When I write log base b of some number a equals to some other number c, it's really important to know how to interpret what you're reading here, okay? And when I say it's important, it's really, really important. The idea here is the word logarithm is just, I want to say it's just a fancy word for saying power or exponent. Okay, that's what this is all about. So all the work you're ever really going to do with logarithms, you need to, in the back of your mind somewhere, you just need to remind yourself that all you're really working with is a power, the power of some number. And in fact, when you read this, the way to read it would be log base b of a number a equals to c. Okay, that's how we read that. But really what I want you to think of is, given that the word logarithm or log is just another way of saying power or exponent, there we go. The way I want you to read this is the power to which we have to raise the base b to get the number a is c, okay? And in fact, there's an alternative way of writing this statement, okay? And the alternative way would be like this. I could go ahead and say that if log base b of a equals to c, that means that b raised to the power of c equals to a. Now, to be clear, these two statements or these two equations are completely equivalent. What that actually means, the word equivalent means this can only be true if this is true, and this can only be true if this is true. In other words, whether you write this or that really makes very little difference. They're completely equivalent statements. So here I'm working with A, B, and C, but if I actually throw some numbers in there, it makes a lot more sense. And I'll give you a quick example. Let's say we have log base 2 of 8. Okay, and we need to figure out what that is equal to. I'm sure you all can already, okay? Then this is going to be equal to some number x. Okay, now if you follow the tutorials I sent you yesterday, I'm pretty sure you know what this is already. Nevertheless, in case you didn't, or in case you missed it, I'm just going to review the method here. Following up on what I just said here, I can actually rewrite this equation in exponential form, in this format here. In other words, I can go ahead and rewrite this as 2 raised to a power of x has to be equal to 8, where this 2 is the base of the logarithm, x is the power to which we're raising the 2, and 8 is the output value, or the result we actually want. So, the trick for solving any equation like this, and this is known as an exponential equation, the trick for solving any of these is to make sure that both sides of the equation are written as powers of the same base. In other words, powers of the same number. Here, the left-hand side is written as a power of 2. So I want to make sure that the right-hand side is written as a power of 2 as well. Now, it doesn't take too long to see that, or to remember that 8 is equal to 2 to the power of 3. Consequently, I can say that 2 to the power of x equals to 2 to the power of 3. Now that both sides of the equation are written as powers of the same number, or rather powers of the same base, I can actually get rid of the base 2 altogether and simply state the final answer as x has to be equal to 3. Okay? And that's done. That approach that I just followed, in which I rewrite the logarithmic equation, that's what this is here, as an exponential equation, is exactly the approach I want you to follow when solving these. Okay? When we get to IB, it's also going to be the approach I'm going to ask you to follow there. So what I'm going to ask from you right now is I'll just give you, really, it won't be long at all, maybe 4 minutes to work through these. And in the meantime, whilst you're working on that, I'm also going to answer one of the questions I'm seeing there, Hugo's question, in which he's asking me what the end of the year exam will be on. Okay? So with a piece of paper, pen and paper, start working on these, and whilst you're working, you're going to hear my voice, and I'll explain exactly how the end of the year exam will work. Okay? All right. Get started on those, and with you. Okay? All right. That being said, if I start working through these, the first one here, if I look at log base 2 of 32, the first step I'm going to do is say, okay, well, it's got to be equal to something. Okay? And I'll say that something is x. Okay? Now, and in fact, if I copy that over there, I'll just move things around a bit. I'll just do this. Oops. There we go. Sorry. Now, if I look at I shall just do it here. Log base 2 of 32 equals to x. The first thing I want to do is rewrite this logarithmic equation as an exponential equation, right? So for that, remember, the first thing I'm going to use are the two equivalent statements that I started off with at the top here. Okay, so really make a note of those two equations at the top if you're not comfortable with those. Really, 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 please make a note of them. Now, back to this, I can rewrite this in its exponential form using what I wrote in orange here, and I can go ahead and say, okay, well, this means that 2 to the power of x has to be equal to 32. Okay, that's question A. The approach now is to go ahead and ask ourselves, okay, well, the left-hand side is a power of 2. Is it possible for me to write the right-hand side as a power of 2 as well? And, you know, the powers of 2 are, for lack of a better word, awesome because they're so easy to find. Okay? You know, you got obviously 2 times 2, then keep on going. So 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32. So we quickly find that 32, if you do it on paper, you'll see immediately, that 2 to the power of x equals to 32, which is 2 to the power of 5. Okay? Now looking at this equation, both sides of it are written as powers of the same base, 2. Okay? So since they're both written as powers of 2, we can get rid of the base altogether and say that, all right, well, x must be equal to 5. And that's the answer. Log base 2 of 32 is equal to 5. Okay? Now, if on top of that, I go to question B, and I look at log base 3 of 27, okay? We'll say that's equal to some value, x again, so log base 3 of 27, and that's equal to x. Okay, now same approach again. The first thing I'm going to do is rewrite this as an exponential equation. Okay, so I'll go ahead and say, all right, well, this means that 3 to the power of x has to be equal to 27. Now I'm sure you can figure it out. What power would I have to raise 3 to get 27? It doesn't take us too long again, right? I mean, we know that 3 squared is 9, and if I multiply that by 3 again, well, I get 27. So that suggests, or that tells us, that 3 to the power of x is equal to 3 to the power of 3. Now that both sides of this equation are written as powers of a same base, which is 3, we can get rid of that base altogether and state that x is equal to 3. Done. Okay? Therefore, going back to this result here, I could state that log base 3 of 27 equals, and in fact I'll go ahead and write it, equals to 3. And I'll write that right there. And I'll do that for the first one as well, just for the sake of being consistent. I'll write that the first one was in fact equal to 5. Good. Now if we look at the third one, okay, log base 10 of 10,000, okay? Now, log base 10 we'll be working a lot with very soon, and you'll see why. So if I look at log base 10 of 10,000, again, I'll just say that, well, that's equal to something, which will be original, and call it x again. Now, first step again, rewrite this logarithmic equation as an exponential equation. In other words, go ahead and say that that means that 10 to the power of x equals to 10,000. And now it's really just a matter of knowing your powers of 10, right? I mean, 10 to the power of 2 is 100, 10 to the power of 3 is 1,000, 10 to the power of 4 is 10,000. And that's exactly what we're after. So we can go ahead and say that 10 to the power of x equals to 10 to the power of 4, and therefore x is equal to 4. Done. And I can complete the result over here. That's equal to 4. Okay? Finally, before we move on to more complicated examples, we have this one here, log base 7 of 49. So I'll just copy that on the far right-hand side here. Let's see if I do log base, I'll write that up here, log base 7 of 49. Now, once more, log base 7 of 49 has to be equal to something, and as always, we'll be original and call it x. And I now rewrite that in exponential form to say that 7 to the power of x has to be equal to 49. This one I'm sure you can get immediately. I can rewrite 49 as 7 to the power of 2, right? So 7 to the power of x equals to 7 to the power of 2, and therefore x equals to 2. We're done. We can therefore state that log base 7 of 49 equals to 2. And there we have it, okay? Now, all of those examples are relatively simple, okay? At times they get more complicated though. In particular, they could be involving fractions and decimals, and there can even be some. As soon as I'm set on that, I will communicate that with you. On that note as well, you'll see it underneath this video, you'll be able to see in the description a link to the answer key for yesterday's exercises. And in fact, if you click on it, you'll be able to see all the answers to the homework I gave you yesterday. Okay. On top of that, you also see links for the lessons that we're going to be covering today. So if ever you don't take good notes or something, it's all there with tutorials and all the rest. Okay, that being said, let's move on to something more complicated, okay? Now, in this case, we're going to be looking at logarithms with decimals, okay? The idea, of course, is still the same, but of course it involves a bit more work. And here's how that's going to work. If I look at this very first example, and I'll just copy it at the top here, we need to evaluate, let's see, log base 10 of 0.1. Okay. Now, when we first look at that, that may be a bit, off-putting, or it may come across as a bit tricky. But again, follow the same steps really. Always keep in mind that if, and I'll write it again at the top, if ever I'm told that log base b of some number a equals to, I'll say x this time, x, then that is completely equivalent to writing b raised to the power of x has to be equal to a. Okay, so remember, this is the logarithmic equation, this is the exponential equation. And so the whole idea for solving these is to rewrite the logarithmic equation, which I'll go ahead and say is log base 10 of 0.1 equals to x. I want to rewrite this logarithmic equation as an exponential equation. In other words, I can just go ahead and state that 10 raised to the power of x has to be equal to 0.1. Okay? Now, with this in mind, what's really important is you need to be comfortable with conversions from fractions to decimals, from decimals to fractions, and to really, practice on those. If you're not comfortable with them, that's going to take some work. This first example, though, if you just read this number out loud and actually say what this is 1/10, right? And because it's 1/10, by very definition, what 1/10 is 1 over 10. That's what that number is called. Okay, so that's 1/10. But now, remember, thinking back of the previous slide, what we're after here, we want to write both sides of this equation as a power of the same number. And in this case, we want to write both sides as a power of 10. But here, the 10 is on the denominator, which can be a bit off-putting at times. But what you need to remember is the very, very, very important result for these questions, which is if I have anything like 1 over a raised to the power of n, I can always rewrite that as a simple power of a, and I can do that using negative exponents. Meaning 1 over a to the power of n is in fact just a raised to the power of negative n. Okay? So again, this is an important result. Make a note of it if you had forgotten that. Now with that in mind, and the fact that when I write 10, what it really means is 10 to the power of 1, I can go ahead and rewrite this whole thing as 10 to the power of x equals to 10 raised to the power of negative 1. Simple. Okay. Now that that's done, both sides of this equation are written as powers of the same base 10. But now since it's raised to the same base 10, I can get rid of the bases altogether. Okay, and I can just equate the exponents. In other words, I can now go ahead and say, all right, well, x equals to negative 1. Done. That's the answer we're after. So the first logarithm here, log base 10 of 0.1, is actually just equal to negative 1. Okay? And that makes sense if you think about it, because remember, all that a logarithm gives us, the output value of a logarithm, is the power to which we have to raise the base. So if you look back at this guy right here, this line, the power is quite clearly negative, right? So it's got to be a negative value at the end. It has to be. Now, with that in mind, I'm going to give you, really not long, of course, so we'll keep this going, so I want us to move on with this. But I'll just ask you to try doing quickly, saying really, when I say quickly, 2-3 minutes, the next 3 questions, B, C, and D. Okay, just give those a quick go. And I'll be quiet, not say a word. If there are any questions there, I'll happily answer them while you're working. But just give those B, C, and D a quick go, and then I'll... Okay, I'll correct question B. Let's say, if I look at question B, we have log base 2 of 0.25. Okay? Now, again, like I said at the very beginning of this, what's really, really, really important for these is that you're comfortable converting fractions and decimals, okay? So, here's the idea. I'm going to start as I always do, and I'll just go ahead and say, okay, well, this has got to be equal to something, so I'll call that something x. Now, I'm going to rewrite this logarithmic equation as an exponential equation, and for that, I go ahead and say, all right, well, this means that, let's see, 2 raised to the power of x has to be equal to 0.25, okay? And now, because this is a decimal, really your first step is rewrite that as a fraction, okay? Now, and this is where all the stuff, you would have done typically end of grade 8, beginning of grade 9, I know we did quite a bit last year of fractions. This is where you want to make sure that you're comfortable converting the two, okay? Now, 0.25, and in fact, I'll kind of use a sort of a gray pen here, just as though it's my scratch pad or something. 0.25, just keep in mind that's 1 over 4. Okay, that's 1/4, right? So with that in mind, I can quickly go back to my equation here and start by saying, okay, well, this means that 2 to the power of x equals to 1 over 4. Okay, and that's my initial instinct, is to think 1/4. Now that I've done that, and now that I've actually written it as well, I can now see, all right, well, that's fine. I can write this 4 as 2 to the power of 2. And I'm thinking of that because my end goal here is to write the whole thing, both sides, as powers of 2. So if I replace 4 by 2 to the power of 2, let's see, that becomes 2 to the power of x equals to 1 over 2 to the power of 2, right? Now that that's done, I go back to the result that I circled or sort of bubbled here in green to write this 2 to the power of 2 as 2 to the power of negative 2. Yeah? So I can now say that, all right, well, 2 to the power of x equals to 2 to the power of negative 2. Okay? Now that's done. We're nearly there. I'll just box that sort of intermediate result. Now that that's done, all I have to do is equate both sides of the equate both of the exponents. Remember, the rule is you can only get rid of the base, or the bases, I should say, which in this case we have 2 on both sides as the base. You can only get rid of that if they're the same. So I can now just go ahead and say, well, therefore x equals to -2. Yeah, that's the answer. And so I can go ahead and state that log base 2 of 0.25 is -2. Okay, I'll look at the next one, question C. Now for question C, we have log, let's see, I'll just write it right here, log base, what is it? Log base 8 of 0.125. And again, let's just say it's equal to x. Now it's got to be equal to x, and so first thing I do, rewrite this as an exponential, like this, okay? So, sorry, not like that, I'm pointing towards the wrong thing. Rewrite this logarithmic equation as the exponential up here. So for that can be rewritten as 8 to the power of x equals to 0.125, yeah? And now again, this is one of the sort of, I want to say classics of converting decimals to fractions, okay? 0.125, you have got to know and are expected to know at IGCSE that 0.125 is equal to 1 over 8. And in fact, if I were to add a value at the top here, 0.5 equals to 1 over 2, hopefully you can see what's happening. Each time I'm just multiplying it by half, so I'm dividing by 2 each time. And that's why these denominators just go 2, 4, and it would carry on that way. Okay, so if that helps, worth keeping in mind. So, and with that in mind, I should actually say, I can now rewrite this as 8 to the power of x equals to 1 over 8. But 1 over 8 means, remember this, 1 over 8 means 1 over 8 to the power of 1. And therefore, 1 over 8 is actually 8 to the power of -1. So 8 to the power of x equals to 8 to the power of -1. Now, I have both sides of my equation written as powers of the same base. And so I can just go right ahead and get rid of the base altogether and just say, okay, well, x equals to -1. And we're done. That's the answer. So log base 8 of 0.125 is equal to -1. Yeah? We carry on. Let's look at question, well, we may as well, we'll see if we have time to do all of them. We'll look at question D. So log base 3 of 1 over 27, okay? Now this one, yeah, definitely let's do this one because it's slightly different to the others. In this case, I'm not giving you a decimal value, I'm actually giving you a fraction inside that logarithm. And I mean, the good news is, what that really means is there's less work for us, so that's good. Log base 3 of 1 over 27, first step, again, I take the initiative of saying, okay, well, that's got to be equal to something, and I'll call that something x. Now I rewrite that logarithmic equation as an exponential equation. So I can go ahead and say, well, this means that 3 raised to the power of x has to be equal to 1 over 27. Okay. Now, my focus is on this 27. Okay, and just putting things in perspective, if you're sitting an actual IGCSE exam, or when you end up sitting the IB exam, if it's a non-calculator paper and you're asked to solve this, even if you don't see the power of 3 right away, in other words, if you don't see 27 as a power of 3 immediately, just always remember what you're doing. You're sitting a non-calculator paper that you're expected to know how to solve by hand. So somewhere along the line, you've got to be able to write this 27 as a power of 3. So even if you don't see it right away, just think, okay, well, 3 times 3 is 9, and then times 3 is 27. If it were a bigger number, carry on, keep on going that way, and you'll eventually find the right power. So I quickly find here that 3 to the power of x equals to 1 over 3 to the power of 3, right? Now that that's done, I can go ahead and rewrite this 3 to the power of 3 on the denominator as a simple power of 3 using negative exponents. Indeed, I can now go ahead and say, all right, well, 3 to the power of x has to be equal to 3 to the power of -3. Yeah. Now that both sides are written as powers of the same base, I can get rid of the base altogether and go ahead and say that x has to be equal to -3. And that's the answer we're after. Okay, so that's equal to -3. Good. I'll quickly work through E and F, and then we move on to more complicated. Okay. Let's see, we have E. We have, and will that fit on the screen there? Let's see. Actually, I'll do that on the far left-hand side. Sorry about that. I'll just go back over here. For E, we have log base 9 of 1 over 81. Okay. Now again, my first step is to say, well, that's got to be equal to something, and I'll go ahead and call that something x, right? And just to avoid confusion, I'll make a separation line right here. There we go. Okay, I'm going to go ahead and call that x, and now using what we saw previously, my first step is rewrite this whole thing as an exponential equation. So that would mean that 9 raised to the power of x has to be equal to 1 over 81. Now, our job is, okay, let's focus on this guy on the denominator, this 81. I'm sure you're quite comfortable in seeing that 81 is 9 to the power of 2. So I can go ahead and see that, okay, well, this is 9 to the power of x equals to 1 over 9 squared. Now I go back to the result I had circled in green here, and I use negative exponents to say that 9 to the power of x has to be equal to 9 to the power of negative 2. Finally, because both sides of the equation are now written as powers of the same base, I can get rid of the base altogether, and I can go ahead and state that x is equal to negative 2. Done. That's the answer. Equals to negative 2. One last one before we move on. Question F. Now in this case, I only threw that in there to make sure that we could sort of, how would I put this? Sort of complete this list of must-know conversions from decimals to fractions, okay? And here's the idea. If I look at question F, I'll try and make that fit at the top here, far right-hand side, F, okay? We have log base 5 of 0.2. Again, I'll go ahead and say that's equal to something which we'll call x. And our first step is to rewrite this logarithmic equation as an exponential equation. Okay, we know that by now, but I'll say it anyway. So that means that 5 to the power of x has to be equal to 0.2. Now, what's 0.2 is a fraction? Okay, and again, it's one of those that you have to know. And in fact, I'll add it to the list at the top here in gray. 0.2 is equal to 1 over 5. It's 1/5. Okay, so if ever you weren't fully comfortable with these fractions, make a note of them. Okay, make a note of them and learn them, because they could be on the exam, my end of year exam. They could definitely have been on the IGCSE exam, and they can definitely be at your IB exams. So these fraction to decimal conversions you have to know. With that in mind, though, I can now state that 5 over x is equal to 1 over 5. Now that's 1 over 5 to the power of 1, of course, and so that's actually equal to 5 to the power of negative 1. Now, I have both sides of the equation written as a power of 5, so a power of the same base. I can therefore get rid of the base altogether and state that x has to be equal to negative 1. And that's the final answer. So log base 5 of 0.2 is equal to negative 1. Okay? All right, we're going to move on. I'll move on to the next page. Okay. Now, just look at these for a second. And actually, because everything is shut, the schools are shut and confined, as you know, my daughter has to start her online session, and I will just forward her the details for her online class. You'll see me do this live on YouTube, which is interesting. And I will quickly send her this. Here are all the details for her online Zoom. Okay. And there we go. Okay, great. So you may hear my daughter in the background very shortly for her class. Anyway, now looking back at these, same approach, right? Same idea as always. We need to evaluate each of those. So even if you're not sure when you start, the first thing you need to do is go ahead and say, well, okay, and I'll copy it at the top here. Log base 9 of 27 has to be equal to something. So I'll go ahead and say it's got to be equal to x. Now again, my objective, my starting point I should say, is let's rewrite this as an exponential equation. So for that, I'll go ahead and say, right, well, 9 raised to the power of x has to be equal to 27. Yeah. If you look at this now, just looking at this, you may already feel, okay, this is nasty. And the reason for that is simply because unlike all of the other examples I have given you so far, when we look at this, it's quite clear that 27 is not a power of 9. In other words, keeping in mind that the end goal here is to write both sides of the equation as a power of the same number, this is definitely more complicated because, I know that, okay, well, you have 9 to the power of 1 is 9, 9 to the power of 2 is, what's 9 to the power of 2? We carry on, 81, then we're going to carry on and so forth, and so on and so forth. But there's no way you're going to be getting a 27 from a simple power of 9 at least. So what we need to look for, and this is why this is trickier, or more tricky I should say, what we need to look for is a base that both of these numbers, 9 and 27, actually have in common. Another way of saying that would be, okay, can you think of a number that you can raise to some power to give you 9? And then can you think of that same number, which when raised to a different power, will give you 27? And I'm sure, hopefully, you've triggered on that and realized that, well, let's see. I know that 9 is 3 squared, right? 9 is 3 squared, and 27, well, 27 is 3 cubed, right? So that should allow me to write both sides of this equation as a power of 3. So I want to say that's the base they both have in common. And so with that in mind, I'll go ahead and say, okay, well, if I replace my 9 by 3 squared, so that would be 3 squared. And in fact, I'll do this in parentheses, and I would suggest you do the same. Okay, you'll see why in a minute. And that's going to be equal to, well, 27, which is 3 cubed. So I can write 3 cubed here. Yep. Now, for this, we're pretty much there. I mean, you can see it already, right? But both sides of the equation are now pretty much written as powers of the same base, 3. But now what I can do is use the following law for exponents, which I'm going to remind you of right here. If I have a number a, which is being raised to a power m, right, and then I raise it to another power n, then that's equal to a to the power of m times n. Okay? And I'll go ahead and bubble that result. Okay? Really important result. Make sure you make a note of it if you had forgotten. Because using that, I can now go and take care of this 3 to the power of 2 to the power of x. Okay? And I can now go ahead and state that that's the same thing as 3 to the power of 2x equals to 3 to the power of 3. And now I'm back where I'm this is exactly where we want to be. We have both sides of the equation written as powers of the same base, which in this case is 3. Okay? Now that that's done, I can just get rid of the base altogether and state that 2x has to be equal to 3. Right? All I have to do now is solve. Dividing both sides of this equation by 2 leads to x equals to 3 over 2, which you could, if you want to, write 1.5. And that's the answer. X has to be equal to 1.5, or 3 over 2. In fact, I could go ahead and write that at the top here. That's equal to 3 over 2. Okay? With that in mind, I'll give you, I'm looking at the time on my clock, it is 3:04. I will give you, I'll just say 2-3 minutes to try the next one. Okay? Try log base 81 of 27. And really, just a minute or two, and okay, let's go. So if I start with, well, I won't start, I'll carry on, I should say, with question B. We're trying to solve or evaluate log base 81 of 27. Okay. Now again, the starting point, just call it something, call it x. If you don't like x, call it y, call it p. Completely up to you, it doesn't matter. Okay. Now, that's my logarithmic equation. I'll go ahead and rewrite that as an exponential equation. For that, I go ahead and state that, okay, well, 81 raised to the power of x has to be equal to 27. And again, I mean, it's not obvious what the power is, right? It's far less obvious than the first few examples we had seen. So the first thing, or rather what I'm really after right now is I want to find a common base that I can raise to different powers to give me both 81 and 27. Okay? Well, when you have something like 27, you really want to be thinking, okay, well, yeah, okay, I'll use 3 cubed again. But 81, the first thing that comes to my mind, at least, when I think of 81, and I'll do it in gray on the far right-hand side, the first power I think of when I look at 81 is I think, okay, that's 9 squared. And if that's the case, that's perfectly fine. You know, you can still get to the right answer with your 9 squared. Because presumably, when you look at 27, or at least with enough practice, when you look at 27, you'll also be thinking, okay, well, 27 is 3 cubed. Yeah. But so immediately when you look at these two things, like, okay, we have a problem here because it needs to be the power. I need to have both numbers written as powers of the same number. Okay, so for that, I need to be thinking, okay, well, I can replace 9 by 3, right? 9 is 3 squared. So you could be thinking, okay, well, 9 squared is actually 3 squared squared. And therefore, using the rule that we have at the top here, 9 squared is in fact 3 to the power of 2 times 2. In other words, 9 squared is 3 to the power of 4. And that's it. Okay? So 81 is 3 to the power of 4. And 27 is 3 to the power of 3. So with all that in mind, I can go ahead and say, all right, well, that means that 3 to the power of 4 raised to the power of x has to be equal to 3 to the power of 3. Now, multiplying the exponents on the 3 here, that leads us to 3 to the power of 4x equals to 3 to the power of 3. And I saw Lev's comment there. Yes, you're absolutely correct with the answer you wrote. Quickly leads to, I've got both sides written as powers of the same base, so I can get rid of the base altogether and state that 4x equals to 3. And therefore, dividing both sides by 4, that leads us to x equals to 3 over 4, or 0.75. That's the answer. Okay, and I'll go ahead and write that at the top here as well. That's equal to, I tend to prefer fractions, so I always write my results as fractions. Log base 81 and 27 is 3/4. Okay. Okay, I'll give you, literally, I'll just, take a brief, have a sip of coffee while you guys try. Okay, so let's see, log base 8 of 4. Looking at that. Looking at log base 8 of 4. I want to go ahead and call that, some number. So I'll just say that's equal to x. So the first thing I want to do, remember, is rewrite this as an exponential equation. So I can go ahead and state that 8 raised to the power of x is equal to 4. Okay. Now, with that in mind, remember that the objective is to write both sides of the equation as powers of a same base, so powers of the same number. And you can go ahead and try, but if you look at the various powers of 4 that we have, or at least the simple powers, integer powers, you'll have 4, then you'll get 16, and so on and so forth, but you're not going to get 8. So what we're going to look for here is a common base, okay? And looking at both of these, hopefully you can see that, yeah, okay, well, 4 is 2 squared, and if I multiply 4 by 2 again, I get 8. So 8 is 2 cubed. And so I can go ahead and say that, okay, well, the left-hand side is in fact 2 cubed raised to the power of x, and the right-hand side is 2 squared. With that in mind, I now multiply the exponents on the 2. So that leads us to 2 to the power of 3x equals to 2 to the power of 2. And now that both sides are written as a power of the same base, I can get rid of the base altogether and state that 3x equals to 2. Finally, all I have to do now is divide both sides by 3, and that will give me x. And so x is equal to 2 over 3. Done. That's the answer. Now, don't write that one as a decimal, by the way. 2/3, with your mentioning what I said earlier on, converting from fractions to decimals, you don't want to write 2/3 as a decimal, really, because that's equal to 0.6666 recurring. It goes on forever. If you really want to, you make sure to write it as 0.6 with a dot on top. But for all practical purposes, I mean, anything like 2/3 or 1 over 6, just leave it as a fraction and say that that's equal to 2/3. Okay? Now, let's look at the last one. Very last one. And I'll just get the right pen there. There we go. So question D. And actually, you'll be able to see that. No, I think I'll move that to the far left-hand side. Okay, so if I look at question D here, we're looking at log base 36 of 216, right? Now, in this case, I'm again just going to start by saying, okay, well, that's got to be equal to something, and I'll go ahead and call that something x, okay? Now, given it has to be equal to x, and using the fact, well, the fact that I can rewrite my logarithmic equation as an exponential equation, I'm going to go ahead and state that this means that 36 raised to the power of x has to be equal to 216, okay? And, you know, looking at this is quite clear. We don't easily see how to get from 216, how to write 216 as a power of 36, right? That's not simple. So our next step really is, okay, can we find a base that both these numbers have in common, okay? And, you know, the trigger in my view is definitely the 36. In other words, when I'm looking for the base, the number I'm looking at is, for lack of a better word, the easiest one possible. So when I look at 36, I think, okay, that's six squared, right? So on my scrap paper over there in gray, when I look at, and I'll just box that initial stuff there. When I look at 36, I'm thinking, okay, well that's 6 squared, no problem there. But how do I get from, how do I write, or can I write 216 as a power of 6? And let's try. For lack of a, when we're stuck, you just, power through, just try it. So if you try multiplying 36 times 6, then that's equal to, that's equal to 216, okay? So, in other words, 216 is actually equal to 6 to the power of 3. Sorry, that's my daughter screaming in the background there. Now, if I now go back to my equation and write both sides as powers of 6, we have 6 raised to the power of 2 raised to the power of x, which equals to 6 raised to the power of 3. Yep. Now, if I take care of the 2 and the x, this quickly turns into 6 to the power of 2x, which equals to 6 to the power of 3. Now that both sides are written as powers of 6, I can go ahead and state that 2x equals to 3, and therefore x equals to 3 over 2. That's the answer. X equals to 3 over 2. Okay, done. All right. Now, with that in mind, we're going to leave this part behind us, and I'm going to be sending you guys a worksheet. Don't worry, not today. But next class, one of the periods will be spent with you guys working on a specific worksheet I have ready for you guys. But for now, I want to introduce you, because it's now, I'm looking at the time, it's 3:15, and we had, I think, seen a bit of this in class. Unfortunately, my little sort of folder where I keep track of everything we had covered, the main one is actually in my office at school, which I can't get to. But I'm pretty sure we had touched base, I want to say, on the next topic we're going to see, and those are the laws of logarithms, okay? So if I go ahead and move to the next page, okay, we're going to start with the addition rule, which is one of the laws of logarithms, or rules for logarithms that we need to know, okay? And I'll just go ahead and actually state what the rule is. Let's see. Let's say I have two logarithms that are being added. Okay, that's the whole idea here. And when I say two logarithms, I should actually be more specific. Let's say I have log of some base b of a number x. Actually, rather than x, to stick to the notation we had earlier. Let's say I have log base b of some number a. And I want to add to that another log, same base, so I'll just say log base b of a number c. Now, the laws of logarithm tell us that that's actually equal to log base b of a times c. Done. That's the addition rule for logarithms. And you definitely need to make a note of that. Okay, that's one of the rules. There are 3 that we're going to be seeing. Okay, so make a note of that. Now, how do we actually use this? Well, there are several ways we use it, of course, but one of the main things that we'll be using it for is to simplify logarithmic expressions. And here's a quick example, and I'll just write example here. Example. There we go. Let's say I ask you, and typically actually it could be written like this: simplify a, which is log base, let's say 5 of, doesn't really matter what the number is inside here. I'll say log base 5 of 8 plus log base 5 of, let's keep it relatively simple, 4. Okay, let's say we have to simplify that. Now the whole idea here is, I want to say the end goal is to make sure that we only have one logarithm. We don't want loads of logarithms being added and subtracted and all the rest. Now we want to just end up with one single logarithm. And provided that the base on each of the logarithms we're adding is the same, and that's actually essential. Here I'm working with log base 5, here too. If this were a different base, we would not be able to simply use this rule. Okay, that's really important. The base has to be the same. But provided I have this, and the base is the same, then the addition rule tells us that I can just simplify this quite massively and say that this is equal to, and sorry, I'll use a different color for the answer, that this is equal to log base 5 of 8 times 4. So that's equal to log base 5 of 8 times 4, which is 32. Okay? Now, if I look at a second example, and so I'm just going to take it from here. I made the notes on my little tablet earlier on. I'll write a few more of these, and I'm going to ask you to do them. So let's see. If I give you log base 7 of 8 plus log base 7 of 10, then I'll give you log base 5 of 6 plus log base 5 of 2 plus log base 5 of 3, and next I want log base b of p plus log base b of q, and finally if I give you log base b of p plus log base b of p squared. So your objective right now is to write each of these in their simplest form, okay? Meaning I want there to be one single logarithm at the end on the right hand side of each of these. I should say as well, the last two, they're actually very common in IGCSE questions, or IGCSE and IB actually, because of the fact, there are no numbers and they want to see how comfortable you are working with, well, variables essentially. So just using that first rule there, go give those a quick try, okay, for like 2-3. All right, now if I look at the question B, that's a straightforward application of what we just seen. Yeah. So here I can just go ahead and state, well, that's the same thing as log base 7, and because both of these logarithms are written as logs of the same base, I can just go right ahead and say, okay, that's log base 7 of 8 times 10. In other words, that's log base 7 of 80. Yeah, straightforward. For the next one, same principle really, but in this case, hopefully you picked up on the fact that there were 3 logarithms being added together. Each of the 3, of course, is still written as a logarithm of the same base, so this law still applies here, okay? And so I can go ahead and say that, well, this means that log base 5 of, I'll do it in steps, of 6 times 2 plus log base 5 of 3, that's equal to log base 5 of 12 plus log base 5 of 3, and finally, I shall carry on the right hand side, that's equal to log base 5 of 12 times 3, which equals to log base 5 of 36. Done. Okay. Now, in case you're wondering, by the way, notice here that we're only being asked to simplify. we're in no way being asked to evaluate. Evaluating log base 5 of 36 by hand would not be an easy task at all. So don't go ahead and try evaluating that by hand. All your job is right now is to simplify each of these as much as possible. Okay. If I look at the next one, we have, let's see, log base b. I can just, for this one, I could just directly go ahead and apply the rule. I mean, there's nothing more I can do really. So all I can say here is that this is log base b of p times q. Done. Simple as that. For the last one, well, again, we're still working with the same base, whatever it is, it's called b. And they're being added, so I can use this law again. And I can go ahead and state, well, this is log base b of p times p squared. Since p times p squared would be p cubed, that leads us to the final answer as log base b of p cubed. Done. Okay? That's the addition rule. Okay? For the next rule, we're going to look at subtraction. Okay? And again, what I'll start by doing is I'll write it at the top here, and I can go ahead and state that log base b of any number, shouldn't say any number, of a number a minus log base b of a number c, that's always going to be equal to log base b of a over c. Okay? Yeah. And in fact, I'll box that result. Sorry, should have done that over here. There we go. For some reason that log is looking much smaller than the others, so I'll just tie that up a bit. That should be written as log base b of a over c. Okay, that's your subtraction rule, and that, again, really important. It's going to allow us to, well, as you can see, now we're going to be able to add and subtract logarithms. Okay, and so again, if I just quickly take my notes here, and if I look at a quick example, let's say, for instance, just write it over here, example, let's say we need to simplify, let's see, yeah, say a log base 2 of 50 minus log base 2 of 10. Okay. Then using this rule, because both logarithms are written as, well, they're both logarithms involving the same base, so 2 in each case, to subtract this from the first one, I can just directly apply this rule and state that this is equal to log base 2 of 50 over 10. That's equal to log base 2 of 5. Done. Okay? With that in mind, I'm going to give you a few of these to do, and at times they're going to be combinations of addition and subtraction. Okay? Nothing too bad right now, but just to get used to both of the formulas. So if I give you log base 10 of 24 minus log base 10 of 6, then we'll have log base b of p cubed minus log base b of p squared. Then, let's see, yeah, log base 5 of 64 minus log base 5 of 4 minus log base 5 of 2. And finally, if I give you log base b of p plus log base b of p cubed minus log base b of p squared. Okay, so give those a quick try. Okay, the first couple shouldn't take you long at all. Give these say 2-3 minutes. Don't worry if you don't finish them. The idea is just for you to get used to using this formula. Okay, so look at the first one, or I should say, looking at question B. Really, that's a direct application of the rule, so it should take no time. We can just go ahead and state that this is equal to log base 10 of 24 over 6, and that's equal to log base 10 of 24 divided by 6, which is 4. Okay. Move on. Question C. We have log base b of p cubed minus log base p of p squared. So that's going to be equal to log base b of p cubed over p squared. But now remember the laws of exponents that we've seen. If I have a raised to the power of m, and a is any number, divided by any non-zero, actually I should have said non-zero number, divided by a to the power of n, then that's equal to a to the power of m minus n. Okay, really keep that rule in mind, because that's going to be useful for simplifying this. Indeed, I can now go ahead and state that's equal to log base b of p to the power of 3 minus 2, so that's p to the power of 1, which is just p. Next one, I go from left to right. So if I take care of the first two, let's see, we have log base 5 of 64 over 4 minus log base 5 of 2. 64 divided by 4 should be 16, I believe. Hopefully I'm not making any mistakes. Log base 5 of 16 minus log base 5 of 2. And finally, I use the rule a second time here and state that's equal to log base 5 of 16 over 2, which equals to log base 5 of 8. Done. Looking at the last example now. And we have, I'll go from left to right again. And in this case, notice that, we also have something being added here. So we have to fall back on the rule we saw previously for the addition rule. Yeah. And in this case, I can go ahead and say, well, okay, this is log base b of, let's see, we have p and p cubed. Okay, and they get multiplied, remember, because we're adding these two together. So that turns into p raised to the power of 4 minus log base b of p squared. That's equal to log base b of p to the power of 4 over p to the power of 2. And finally, that's equal to log base b of p to the power of 2. And that's the final answer. Okay? Now, there's technically one more law for us to see. Okay? And what I'll do, I'll simply state it for today. Our next class, again, I think I'll stick to running it live on YouTube, if that works. If it doesn't, do tell me by email. Okay, send me an email on the school email, and I'll know. But I think this setup can work. And to finish today's class, though, what I will do is I will definitely at least give you the rule so that it's written down. Okay, so bear with me a few more minutes. So moving on to the next page. Now this is the power rule. It's often also just called the multiplication rule. And, well, just go ahead and write it. Here's the idea. If we have a number x, which is multiplying a logarithm, so I'll say x times log base b of some number a, then that can be rewritten as log base b of a raised to the power of x. Okay? And again, I'll go ahead and box that. This rule, make like a giant poster of it, is probably by far one of the most important rules you're going to be learning about logarithms. And in fact, during our next class, we'll be seeing why it's so important. This rule will actually really provide us with a tool for solving exponential equations. Okay, so do make a little special asterisk or symbol next to this formula, because it's incredibly important and comes up a lot at IGCSE exam questions on logarithms. Now, if I were to quickly give you one or two examples for the sake of finishing today. Let's see if I'll try and take a relatively simple one. Let's see. Yeah, let's make it really straightforward. Let's say, I'll just write example there. Let's say we were asked to write in the form log base b of a. Now what I mean by that really is we want to we want to make sure that any logarithm we write is in its simplest, or I want to say purest form. You know, there's nothing multiplying it at the front, there's no other logarithm being added to it, there's no other logarithm being subtracted from it, really just a simple basic log base something of something, okay? So that's what it means when I write this. And as a first example, let's say I'll give you, okay, let's say we have 3 times log base 2 of 5. Yep. Well, using the rule we have here, we can go ahead and say that this 3 can actually be written as a power on the 5. Okay. In other words, I can go ahead and say, well, this is the same thing as log base 2 of 5 raised to the power of 3. Yep. And now, 5 to the power of 3, well, that's 5 times 5 times 5. And by all means check, but that should be 125. So that's log base 2 of 125. Okay. Carry on. One more example. Let's say we're asked, again, same guideline, write in this form here. And let's say we had to, let's quickly see this. If I did B, and that's 2 times log base 5 of 3 plus 3 times log base 5 of 2. Yep. I want to write that as a simple single logarithm. So got to gather everything together here. And you can probably tell already, you know, we're going to be using more than just one of the rules we've seen here. The first one we're going to take care of is, we'll use this rule right here, okay? Our this nice sort of power rule or multiplication rule. And for, you know, the idea there is to turn these, I don't want these numbers multiplying these two logarithms, okay? So that's the first thing we take care of. And I can go ahead and say that this is the same thing as, okay, log base 5 of 3 to the power of 2 plus log base 5 of 2 to the power of 3. Okay, now just to be clear here, all I'm doing there, to get this 2, that was the 2 multiplying the logarithm. To get this 3, that was the 3 multiplying the second logarithm. Yep. So now that's done, I can go ahead and state, well, this is equal to, I tend to simplify as much as I go along. So I would, you know, as you're doing these, I would definitely calculate the powers immediately before you start adding the logarithms together. So this would be log base 5 of 9 plus log base 5 of 8. Okay? Finally, we use the addition rule we saw to add these two logarithms together. And remember, we can do that, of course, because the base on both of these logarithms is the same. So we use the addition rule, and we can go ahead and state that this is equal to log base 5 of, well, 9 times 8. Finally, since 9 times 8 is 72, we can go ahead and state that this is log base 5 of 72. Done. That's the answer. Okay? Now, in our next class, I'll leave you there because you have basically 1.5 minutes left of class normally at school. So we'll stop there. But in our next class, we're going to carry on with these laws of logarithms. Okay? And we may not go for the whole 2 periods live streaming, but definitely one of them. And I'll just work through, I think the way we'll do it is I'll just work through several examples of how to simplify things as much as possible. Once that's done, I'll be giving you a worksheet to work on and, of course, send back to me. And that will be added to your sort of portfolio. Okay? And there we go. Okay, everyone, let me know if that worked for you, if the sound was good, if there's anything that wasn't working. Really do let me know. Send me an email or something. And that's it. Okay, guys. Take care, everyone.